Hi, my name is Tim Savon. I'm part of the coated M2A scheme here at Swansea University. So I'm in the final year of my Eng.D and my project's looking at development of sensors and non-destructive techniques to analyse the performance of industrial coatings in situ. My specific research involves working with an industrial sponsor, and in my case it's the Colours division of Tata Steel here in the UK, and they're a market-leading steel producer with a focus on the construction sector. Coated steel panels and cladding are already widespread in use, and this is continuing with time, particularly for commercial purposes, and there's an upward trend in modular building manufacturing. So performance of coated steel products is often only estimated from accelerated lab-based weathering testing, such as salt spray testing and things like UV testing. There's a move these days to try and get to sort of more live monitoring. So with the Internet of Things and the development of smart buildings, there's an increased demand for live monitoring of products to see how it's actually performing, rather than basing performance estimates on the lab-based accelerated monitoring testing. The cladding I'm looking at, the coatings on it, they face a number of different conditions in real life service. So one of the areas of my project is to look at how does those conditions vary across a building. So do different geometries create more aggressive or less aggressive conditions, and how can we use this information to target perhaps any inspection, or those areas of concern can be the focus of any sensors I end up developing. As part of my project, I've looked at a number of different ways of monitoring either the steel substrate for degradation or the actual organic coating itself. So some of these methods are non-contact, so they can be done sort of at a distance, and some are ones that would be sort of a human operated system but aim to improve on current techniques as they exist. Some of the key things I've looked at are RFID based sensors, so they offer sort of a reasonable range of detection, and they would allow sort of a semi-remote autonomous method of detecting the corrosion. Other methods I've looked at are embedding thin electrical sensors between the coating layers, and these can detect things such as water uptake into the coating as well as blistering. This sensor technology and the ideas I'm looking at have a good application for Tata Steel, so it helps them to better understand how their products perform, as well as how perhaps they may degrade in different conditions. And it also allows them to offer an additional thing to customers on top of their already comprehensive guarantee, that sort of extra level of security in their product. So I think this work really shows the type of research involved in Eng.D and how it can impact not only understanding academic world, but how it can be linked to industry as well. So as well as just the sort of pure research, we're looking at how this can affect business, and an industry-leading business at that. So I've really enjoyed my time with the coated M2A Eng.D scheme. I think the way it's set up is really good, and there's really good facilities and resources available for students. I like the fact you're part of a big cohort, so there's a sort of group atmosphere, you have a good social aspect to it, and it means you can always sort of help each other out around the labs. One of the main things I've really enjoyed about it is the ability to go to conferences both internationally and also in the UK, and I was very lucky to attend one in Vancouver myself.